What's up, scholars? Let's talk about using congruent triangles. Section 4.5, using congruent triangles. Question, how could I prove that angle PQS, angle P2, whoa, struggling here. Angle PQS, man. It's been a minute since I drew a straight line, I guess. Angle PQS is congruent to angle, what color are we going with? Looks like reddish, RQS. Well, there's two ways we could do this. We could literally measure, and if they have the same measure, then they're congruent. World's smallest protractor is going to do the job for us. Let's see what we've got. You're going to go in the center. So right now I'm measuring PQS, so I'm lining up PQ on the bottom with my 0. My 0 degrees is on the inside. Alright, PQS, this line goes through, looks like between 20 and 30, so 21, 2, 3, 23 and a half, maybe 24 if I fudge it, maybe 23 if I fudge it, somewhere in there, 23, 24 and a half. Okay, well, so let's look at angle RQS, angle RQS, line up the bottom with QR. Zeros on the outside this time. 10, 20, 1, 2, 3. Yeah, 24-ish. So they're the same measure. Could measure with a protractor and show that angles are equal in measure. That's one option. Option number 2, if I showed you that these two triangles were congruent. Oh, that was much better. That was so much better. If I showed you that triangle PSQ, this blue triangle here, if this blue triangle here was congruent to this red triangle here. Why would that be helpful? Well, I know that when triangles are congruent, their corresponding parts are congruent. So if I knew that triangle PQS was congruent to triangle RQS, then I would know that those corresponding angles right here would be congruent, because that's the definition of congruence. Right? So I could show that, let's use our colors, let's have a good time. Triangle PQS was congruent to triangle RQS. Then we would know that corresponding parts in this case angle PQS and angle RQS are congruent. If we showed these triangles are congruent, then we would know that those angles were congruent. Now, how would we show those triangles are congruent? That part's pretty easy, because we already see a pair of sides are congruent here, a pair of sides are congruent here, SQ is congruent to itself. So we've got two triangles that are congruent by side, side, side. So just as a little note to ourselves, we would use side, side, side. That part wouldn't be very hard. So what we're really using is what we call, in the geometry world, CP-CTC. Congruent parts of congruent triangles are congruent. Congruent parts of congruent triangles are congruent. Right? These corresponding parts, angle PQS and angle RQS, are congruent to each other. Boom shakalaka CP-CTC. When you want to show that some part of a triangle is congruent to some other part of a triangle, you show those triangles are congruent first, and then you know the corresponding parts are congruent. Now you could measure, like we said in number 1, but that time-wise would actually take more time, likely, and 2, I've seen some of you try to use a protractor, which we're still working on. Ooh, burn. Anyway, let's move on to some examples, shall we? Just have to hold it. Weird. Well, that's fine. I'm just gonna move myself over to the side. Hi guys. Go on the tab. You know. Yeah, let's keep that up there actually. CP-CTC. Congruent parts of congruent triangles are congruent. Example number 1. A is the midpoint of segment MT. Well, let's mark up the diagram with that. A is the midpoint of segment MT, which means MA and AT are congruent to each other. A is also the midpoint of SR. A is the midpoint of segment SR, so that means segment SA is congruent to segment AR. That's what a midpoint does, man. It splits things into two perfectly congruent halves. We're trying to prove, we're trying to prove that lines are parallel to each other. How do I know the lines are parallel? I usually try to look for some angles. I usually try to look for like alternate interior angles being congruent. That happens a lot with triangles because they're mostly alternate interior angles. I bet that's what's going to happen here. Just thinking my thoughts, you know. See what we got. I mean, fortunately, they wrote out like literally every step, so we just got to figure out why those things are true. Cool. Statement number 1, A is the midpoint of segment MT and A is the midpoint of segment SR. Those were given. And then we marked up our diagram based off of what those things said, making segment MA congruent to segment TA and segment SA congruent to segment RA, MA, AT, MA or TA, SA and RA. That's the definition of a midpoint. A midpoint splits a segment into two completely equal halves. It's the midway point, the dot in the middle, midpoint. All right, segment MAS is congruent to segment TAR. Girl, that's an angle. Angle MAS congruent to angle TAR. Well, we know why that's true. We could have looked at the diagram and said that like a long time ago. Those are vertical angles, son. Vertical angles. Oops. Vertical angles are congruent. I don't have in a different order the words, but it's good. So now we know, and we knew up here in this picture, we could have been saying this, triangle MAS is congruent to triangle TAR by side, angle, side. Yeah, side, angle, side. So how come angle M is congruent to angle T? Well, if we go back up here, triangle MAS congruent to triangle TAR. M is the first letter, T is the first letter, so that means those are corresponding parts. And since these triangles are congruent, these corresponding parts are congruent. These corresponding parts of congruent triangles are congruent. Yeah, good job. Good job. All right, so then why are segments MS and segment TR parallel to each other? Well, I told you we were looking at angles, man. So let me prove to you what's happening here. Let's extend these lines so they look more like the transversal situation we talked about when we originally talked about proving lines were parallel. And we're looking at segment MS, and we were using these angles here, so I'm going to extend these lines. So again, we're looking at who? These ones right here. This angle M and this angle T. That's who we're checking out. What are those angles to each other in this situation where I've got two parallel lines cut by a transversal? I've got two parallel lines cut by a transversal. Right, that's my M, and that's my T. You see what's happening here? That's our M and that's our T. So we're looking at right there. Those are alternate interior angles, and since we're trying to prove that lines are parallel, it's the alternate interior angles converse. The converses prove that the lines are parallel. Great job. Coming off Thanksgiving, already going right into a proof. Should feel like pretty good about yourself. Yeah. All right, so let's see how we do on number 2. Ooh, y'all only got like a minute and a half left with me. And then you're going to be on your own. Example number 2, if you're given that segment HJ and LK are parallel, and HL is parallel to JK, HL is parallel to JK, use a paragraph proof to show that angle HLK, this guy here, we're trying to show HLK is parallel, no, not parallel, congruent to KJH. That's what we're trying to show. Maybe I need to put that in a different color. That's the part we're trying to show. It's not given yet. That's what we're going for. That's what we're making happen, Captain. Trying to prove that some angles are congruent to each other. Well, we're going to have to prove that the triangles are congruent and then say that those are corresponding parts of those congruent triangles. And that they're congruent to each other. You're going to use CP, CT, C. It's going to have to be how that goes. You